Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework from yesterday. First off, comparing box plots. I think you've noticed this maybe a few times on the homework that I've done and on one of the lessons where I took a histogram and a box plot, and since the histogram references a number line for the x-axis, you're able to use that number line for the box plot as well. So the histogram gives you the frequency of all these different amounts, whatever they may be. This particular graph isn't labeled, so we have no idea what we're counting here. And then the box plot will show you what the median is. The interquartile range is from 3 to 5. The median is 4. The minimum is 1, and the maximum is 8. So you do get some specific information here, and you also get an idea of where half of it is clustered, and you can see in both of them if there are any outliers or not. You take, this is Alejandro's scores. I'm not sure what he's playing, and Caesar's scores, and you can see that Caesar, his minimum score was a 0, his maximum was a 6, and his median was a 2, and the range here goes from 1 to 3. So sometimes you can mix data displays like this because they both reference both the box plot and the histogram reference the number line. But there's also something that's called a parallel box plot. And this is good when you're comparing two sets of data. And you can just look at this and you say, all right, well, everything about Caesar's scores was lower than Alejandro's. His minimum was lower, his median was lower, his maximum score was lower. So who had the lower scores? You can clearly see his interquartile range is one full range underneath Alejandro's. So just another way that you can compare data. Whenever you're trying to compare two different sets of data, you can put the box plots together against the same scaled number line, or you can do something a little bit more sophisticated, like the combination box plot histogram. All right, I'm not a big fan of this question, but let's just take a look at it. It's really the last part, or actually part A, estimate the box plots, what they would look like. I don't really like that question, but we kind of get an idea just by looking at the histogram how the box plot may look. It says the two histograms below show how precisely Lou threw 50 darts with his right hand and then with his left hand. So precisely, is he getting most of them in the right area or in the same area, or are they spread out? This here for the right hand indicates that they're kind of spread out a bit. Here it looks like they're all pretty much toward the center. So it looks like he's both accurate and, I don't know. I mean, I'm not sure this is super precise either because you've got some out here that are 12 to 15 inches away, just like the right hand had a few that were 15 to 18 inches away. I would still say this one is more accurate and more precise because you've got higher numbers of shots going in this range right there than any of these. The highest that they get is 7 shots that were within 9 inches of the target. So I'm going to guess that he's probably left-handed because he's doing better with his left hand, right? And then it says estimate. This is the part I'm not really concerned about. It just looks like the center of the right hand appears to be right here around where the 9 is. So that's where I would expect the interquartile range to go. Whereas here, a majority of them are going to be down to this area. So I expect the interquartile range to be toward the far left. Do they both have numbers in the zeros? Yeah, they both have minimums of zeros. So yeah, looking at the box plot, you see this interquartile range is closer to 0, which means that he's more accurate. And I think the size, it's not as spread out as much. So you'd think that this is also more precise with his left hand. Find the missing lengths or values in the diagram below. Okay, first of all, it's important to know that the scale goes from 0 to 1, because that's 1.0, and it's broken up into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means that those are 10% intervals, and 10% of one is 1/10. So each one of these has to be equal to 1/10. So once you've got that, like let's take 3 of those, that's 3/10. Let's take 4 of these, and that must be 4/10, as well as 40%. And then take what is each one of these? Looks like it goes 1.5. This one is another one that goes 1.5. So each one of them is 15, where the total for both of them combined is the same as what A was, which is 3/10. I should say 15% there, and 3/10 up there. All right, for problem 25. What do we have going on here? We've got Joaquin has agreed to lend his brother $45 so that he can buy a new tank for his pet lizard. Joaquin is charging 2% per month simple interest. So this is an I equals PRT kind of a problem where we want to write down the I, the P, the R, and the T, and then fill in what we've got. Well, the $45, that's your principal. That's the amount that he is borrowing. The 2% is the interest rate, which we're going to write in decimal form. And the amount of time that he's going to be borrowing this money is 6 months. So we're going to plug those numbers in. 45 times 2/100, which is 2%, times 6. So if I were to just figure out how much in interest he was going to pay per month, I would just multiply find what is 2% of 45. And since 10% of 45 is $4.50, then 1% would be 45 cents, which means 2% would be 90 cents. Let's just verify that to make sure I didn't make any simple mistake. 45 times 0.02 is indeed 90 cents. So we could rewrite this as I is equal to 0.90 times T, because every month he's going to have to pay 90 cents. So 6 months he has to pay $5.40. Now that's the amount of the interest, $5.40. What is the question asking? It's asking how much will Joaquin get back? Well, he's going to get back his original $45 plus the interest. So you have to add those two together, and that's how you get your total that Joaquin's brother is going to have to pay him back after the 6th month period. This is an interesting problem that's going to require some conversions. And so I did it 2 different ways here. Michaela holds her state high school record for the 500-meter freestyle swimming event. She can swim the event in 4 minutes and 50 seconds. If she were to continue with this pace for a total of 10 minutes, how far would that take her? Okay, so first of all, this is a mixed measurement. So we either want to convert 4 minutes and 50 seconds into a number of minutes, or we want to convert it to a number of seconds. And then we know that there'll be 600 seconds in 10 minutes, and so we just set up the proportion that way. So I figured 1 minute was 60 seconds, so this is the same as saying 4 minutes and 50 out of 60 seconds. So by writing it that way and then simplifying it, we could call 4 and 5/6 the decimal equivalent of 4.83, but we know that it's actually 5/6. 5 divided by 6 is a repeating decimal. So by rounding this down to 4.83, we're gonna get a slightly incorrect answer. Anytime you round something, it's gonna affect the accuracy. So we can still do it though and get something that's approximate. And here you see my other work down below. Cross multiply, you're going to get 4.83 times x is going to be equal to 5,000. And then when you take and divide 5,000 by 4.83, you'll get this as your answer. Now, as I did this again, I realized, hey, this does not require us to round anything. So this is going to give us the precise answer. If I convert 4 minutes to 240 seconds, because I multiplied times 60, and then add the 50 seconds, that's 290 seconds. Cross multiply, and you get 290x is equal to 300,000. Now when I divide 300,000 by 290, without having to round anything, I am going to get the precise answer. And that is 1034.48. 1034.48. So how different is this than that? Not a lot. Half of a second, maybe. No. These are meters. Half of a meter is about the difference, but this is actually technically the more accurate answer of the two. And number 27, Mrs. Chen has two brothers. Mark is 7 years older than her, and Eric is 11 years younger. So if you make Mrs. Chen the X, then Mark is X plus 7, and Eric is X minus 11. Some of you are still wanting to use the guess and check method, and that's okay, but it would be really good if we would start graduating to the algebra. Mrs. Chen is X. Mark is X plus 7, and Eric is X minus 11. And when you combine all those, you get 1, 2, 3 X's, and 7 and negative 11 is equal to negative 4. And since their combined ages was 149, then we'll make the equation 3x minus 4 is equal to 149, which makes 3x is equal to 153. And when you divide that by 3, you get 51. So that is the age of Mrs. Chen, and that's what we were being asked to declare. Now, to make certain that that's correct, remember, you want to do the check. If she's 51, then Mark is 7 years older, making him 58. And Eric is 11 years younger, making him 40. But when you add those together, 51 plus 58 is 109, and 109 plus 40 is 149, and that's the correct answer. So whether you decide to do guess and check process or solve algebraically, as long as you get the correct answer, that's all that matters. But I think most of you are starting to see the benefits of setting this up algebraically and solving algebraically because it's so much faster, so much easier. And then our last problems. Being able to solve equations that contain fractions and decimals, and this one's pretty straightforward, I think. Let's see what we need to do. Here, to get x by itself, we would have to add 1 1/4 to 2 1/2. So let's go ahead and do that, but let's change 2 1/2 to 2 2/4. Add those, 3 3/4. That's your answer. Here, take away 2 x's from each side. That becomes 3x is equal to 12. I think that's pretty straightforward. And then here you add 14.6 to each side. I guess the trick here is to make sure that you line up your decimals. Other than that, I think those are pretty straightforward problems. And you should be checking your answer just to make sure that they're correct. It is 3 3/4 minus 1 1/4, 2 2/4. Yes, it is. If x is equal to 4, that's 20. This becomes 8 plus 12 is 20. Yes, that's correct. And 22.62 minus 14.6 should get us back to 8.02. Yes, it does. All right. So there you go. That's your homework. Today, we are not going to learn a new lesson. We're just going to have a little check for understanding. Look through the problem, make sure that you're understanding things, and then tomorrow there will be an assessment that'll be counted toward your grade based on what we've been doing this week. Okay, so good luck on everything, and I hope you enjoy the rest of the week and your week off for spring break. Take care.
Hey, feeling good, like I should.